Hi guys. My name is Igor. I'm from POA. POA is a sidechain to Ethereum. Sidechain means a new blockchain started with different settings, but without existing state. And goal of the POA is to bring scalability and interoperability into Ethereum ecosystem. So we're mostly working on tools for Ethereum-based chains and protocols. So BlockScout is an open source blockchain explorer, and the question is why we decided to build our own explorer and not to use something else. The answer is simple, right? There is no tool available for sidechains and forks, which has the same feature set as the main blockchain explorer for Ethereum, which is Etherscan. Right, so we decided to build full-featured explorer and make it friendly to sidechains and forks. Means that we plan to support Classic, POA, Ethereum itself, testnets, and any other blockchain which would like to use it. So it's open source and free software, so anyone can install it, synchronize with existing chain, and use it for their chain. It's built on Elixir and Erlang stack, which is created for distributed applications. And the project is community-driven with public Gitcoin bounties. So if any developers would be interested in to participate in solving issues for Explorer, he can be awarded by bounties from Gitcoin. So why Etherscan is not good for us, right? So it's not available for sidechains, to sidechains and forks, so you cannot get it, right? Source code of Etherscan is not public. So for example, if you want to add something to Etherscan, you have to ask and you cannot build, right? Roadmap of Etherscan is not public. You don't know when Etherscan will support new type of token, when it will support new hard fork, new patch set, and so forth, right? When we think about blockchain explorers, usually they contain data from public blockchain, which you can index and process at any time, and also blockchain explorer contains data from user-generated content. For example, token symbols, comments, source code is usually something that you cannot get from the public blockchain. And this data is owned by for-profit company. Well, sometimes infrastructure is not reliable. If you think about CryptoKitties congestions on mainnet, Blockchain Explorer was also not reliable at that time. Sometimes data is censored. For example, on the last consensus bug in Ethereum, Etherscan censored transaction on Ropsten, which caused this hard fork, because they thought it's good for the community to not know how hard fork was created. So that was this split existed on Covenant and some other networks, but basically Etherscan censored this transaction. Okay, so this is comparison with existing explorers for Classic, and I'd like to highlight a feature that we have. BlockScout supports multiple types of tokens. At the moment, it supports ERC20, which is a standard token, and all operations with this token, and ERC721, which is a non-fungible token. Think about CryptoKitties. There is a smart contract verification for Solidity languages. Also, you can query this contract from the UI, so you can enumerate public methods and query with specific requests. It also has full transaction history, so when you start the new instance of the BlockScout, it starts from the last blocks and go back to the genesis, and it indexes a full chain. Right. Also, we decided to have full-featured API. So besides of transactions and balances and blocks, also this API can provide token operations. So let's start with the UI part. Reactive updates. When we it's not the actual speed of blocks creation. It's a bit faster than it is, but reactive update means that we can have reactive updates in the UI without refreshing the page. So if you have the BlockScout open, you will see new blocks coming and also new transactions. And on any screen, when you can have reactive updates, you will get it. For example, blocks, transactions, internal transactions, token transfers, anywhere. Well, the same works for blocks. And I will switch to presentation. For example, this is a deployment for POA, and you can see how blocks appeared in real-world scenario. So blocks created here each 5 seconds, right? And also transaction appeared here. So it's convenient for users and developers to see its real-life updates. ERC20 token. So for ERC20 token, we have the token balances, all token transfers, value transfers, and contract creations. So all types of transactions we can see in the ERC20 token. For example, here is a contract with internal transactions, and you can browse all of them. And let's switch to transaction view. Contract. So source code for token. Let me switch back. For each contract, it's possible to verify source code of contract, and it is stored in metadata of the BlockScout instance. So it's pretty common. Like you can store source code, API, binary interface, and contract creation code. That means that this data is available on BlockScout. It also can be replicated on any other instance if this data will be transferred from instance to instance. So the BlockScout has this interface to export data, data indexed from the chain, and also data indexed from data created by users. What else? It also supports ERC721 non-fungible tokens, the same contract creation and tokens and token transfers and simple value transfers. This token is important for non-fungible tokens, and the BlockScout can be extended to support different schemas for different types of application. For example, if we think about ERC20, we usually have balances and addresses, owners, right? But for ERC721, we have domain-specific data for different tokens. Yeah, think about CryptoKitties. They have different parameters of CryptoKitty, but other type of tokens, for example, some ownership of land registry will have different parameters, and this can be extended within BlockScout, and it's open source, so it means that it's much easier to get these features done by yourself or by R&D company if it's interesting for community. So read smart contract. In the reading smart contract, we can get, so basically all methods are enumerated, and if we can get this information without specifying parameter, for example, an owner of the contract, here's a DAO contract verified on BlockScout Explorer, then this data automatically linked and highlighted. So you can see when you read this contract, there's a DAO creator and it's an account, and we can go through and we can see who is the creator of DAO and when it's happened, and all underlying transactions. So it means that we can create this deep dive experience when you browse data, and you can get insights from this data. And if you need to query contracts, you can specify, for example, if it's a balance of an account within DAO, you can specify this in a query field and query the Explorer. So what else? Yeah, the BlockScout deployed for 3 networks at the moment. It's deployed for POA, for Ethereum mainnet, and for Classic. With interesting insights you can get from mainnet deployment. For example, when you go to blocks, you can see that blocks on mainnet are fully booked, right? And that's what we need in Ethereum Classic, and that's what we need in POA and on other sidechains. And this is a kind of side note, but I think that building tools and interoperability instruments between chains is that what we need to do to get adoption of sidechains and forks. Yeah, you see this block is empty. It's called selfish mining, right? Also, we can get some insights when we're just looking at reactive updates, right? So selfish mining is when miner created a block but didn't include transactions. Why he or she doing this? Because they can start mining new block faster because they don't need to execute all transactions within the block. So they just drop all transactions and they include this block. Well, next miner is not selfish. And you can see that every maybe 20 blocks we have one miner, and that's a distribution of selfish miners in the network. So even without any analytics on the chain, we can get some insights and compare this data with other chains. And for example, when we go to POA, to blocks, we can see that our blocks are empty. Why? Because no one is using the network yet, and it's a big problem for many EVM chains that we have create new, for example, blockchain. Classic has the same security properties as Ethereum, but much less transactions, and also it's much cheaper. So we need to attract developers. How can we do this? And we think that building tools and making interoperability between chains is something that we can bring today to get adoption to side chains. Right, and also I think that instruments we're building should support all EVM instances because we're working in the same ecosystem, and we're interested in having this ecosystem growing and have different options for developers to choose from. Right, so the BlockScout supports API, and all API endpoints are documented, and you can try them out through this API endpoint. Well, the simple API like balances, and it's quite easy to make, but API like tokens and statistics for tokens are quite interesting, and that's what we have at the moment. And these features are the same as on Etherscan. So when you think about BlockScout, it's the same experience as Etherscan, but open source, so anyone can participate. We're located at poa.network/BlockScout, so it has extensive documentation. You can download and set it up for your network, and it's quite easy to deploy. Also, if you plan to deploy it in production, we have a deployment script for AWS. It's called BlockScout Terraform. So on BlockScout Terraform, there's a Terraform deployment script which can deploy your infrastructure on AWS compatible environment. So it's good if you plan to deploy this Explorer for production use. Also, it can be used on a standalone computer as a blockchain explorer for development purposes. So you can start your private network on your computer and point BlockScout on this private network and get blockchain explorer experience on your developer node. So it requires to install Elixir and Postgres and Node.js, but if you're a developer, most likely you'll have these tools on your computer. Or it's quite easy to install. Yeah, if the network is not large as Classic or Ethereum mainnet, it's quite easy to deploy this tool on your computer. So what else? The best way to participate in BlockScout development is participate in our issue tracker, and you can see that we prioritize them, and we have a roadmap. The R&D cycle is we distribute it into 3 parts. We have a section with developer experience for verification of smart contracts and other tools for developers, like API tools. And we plan to support more languages. At the moment, we support Solidity, but we plan to support Viper and WebAssembly when it will be live on networks. We have a contributors section. Contributors we usually call token holders. This is a part of Blockchain Explorer where holders of tokens or native coins are interested in getting information as fast as possible, and that's what is making Etherscan attractive for users. And also we have a third section about architecture, about indexing and making this indexing reliable and distributed and so forth. Right, so there are 3 sections, and here you can see how far we are from the release. The software is in alpha version at the moment, so we plan to release it near DevCon 4 in end of October. And we will host BlockScout for Ethereum mainnet, for Classic, for POA and other sidechains which will be interested in having them. So what else? Yeah, so that's how Ethereum Classic interface look like. And you can see the same interface, the same experience for any chain. For example, this is Classic, right? This is Ethereum mainnet and POA. And the difference only in skin, and the difference is in some small changes networks have. For example, different patch level, and we'll support this patch level for different networks. And yeah, that's basically all I want to say about POA BlockScout Explorer. Let me know if you have any questions. No questions?
Awesome.
Yeah. We have like 3 minutes. I'd like to take at least one question. Maybe.
So does anybody have any questions? Oh, right over there. I'm coming.
Hey.
Hey, thanks for the talk. It's really good. I'm just wondering, how do you get the ABIs so that you can show all the, and also the source code? Like, do you have to upload it, so, like similar to other blocks?
Right. Yeah, that's when I mentioned problems with Etherscan, that some data you can get from blockchain, right, and some data you cannot. So source code and ABI is user-generated content, right? So someone should upload this code. But when we think about this source code uploading, we think that we should be able to extract it and synchronize between instances, right? Because, for example, if someone verified smart contract on Ethereum can be verified automatically on Classic, and Etherscan sometimes doing this under the hood, but we don't know exactly, right? And we cannot optimize it, modify, and see if source code is really compiled or not, right? Because you can get this, okay, source code verified, but you can, you have to verify it yourself to prove.
All right, and we got another question over here.
I'm wondering how your indexing process works. I mean, do you keep everything on Postgres database, or using Postgres and some RPC API together, and how long it takes to index?
Yep. So yeah, at the moment we're indexing everything in Postgres. So selection of Postgres is because it's a natural choice for Elixir language, and it has the best drivers, and also it's scalable on cloud providers like AWS. We start indexing from the last block and going back to the Genesis block. And also when indexing the chain, we use all these transaction receipts. So you have to have a full archive node with tracing. For Classic, it takes about 10 days on 36-core instance with 512 gigs of RAM with 4 terabytes SSD disk to index all ERC20 tokens. And yeah. So, and also it's about a day to synchronize the full node with tracing and archive. Well, but when you have this synchronized, you just make snapshots and you recover from snapshots. So we don't need to have these nodes, easy synchronized for the first time. But later on, we need to have them easy recovered after failures. So that's what usually we have in kind of enterprise systems. And I think Blockchain Explorer is this type of system, right? OK, guys.
Absolutely.
Thank you.
Anything else?
Anything else?
Last chance? OK. Last question.
Do you think you could pull up the Ethereum Classic page?
Yeah, it's under deploy. We are redeploying it right now, and yeah, this is the Ethereum Classic page. The documentation how to deploy it for Classic will be available today on our GitHub. So.
I like the green color scheme on the line.
Yeah, that's colors of Ethereum Classic. We just use the default colors. Yeah.
Yeah, great. All right, once again, thank you to Igor for the presentation on BlockScout.